always realize carbon monoxide as a pollutant, right? Nevertheless, carbon monoxide is much more important. Recently, it has been discovered that carbon monoxide is produced inside an organism and low doses of carbon monoxide have exhibited beneficial effects in the suppression of organ graft rejection. Hence, synthesis of carbon monoxide releasing metal complexes or particularly metal carbonyls have been greatly looked into. In this context, we may discuss the different types of metal carbonyls and their structures. Metal carbonyls are coordination complexes of transition metals with carbon monoxide as ligand. They can be homoleptic or heteroleptic. Let's limit our discussion to homoleptic complexes. Most of the transition metals form homoleptic carbonyl compounds. A homoleptic complex is a complex that contains only one type of ligand, that is, they contain only carbonyl group as a ligand. For example, tetracarbonyl nickel 0. These carbonyls have simple, well-defined structures. See here, tetracarbonyl nickel has tetrahedral structure. Other examples of homoleptic metal carbonyls are pentacarbonyl iron 0 complex, which has trigonal bipyramidal structure, and hexacarbonyl chromium 0 with octahedral geometry. Have you noticed so far we discussed metal carbonyls with only one metal atom as a central atom. These are called mononuclear metal carbonyls. Now we will discuss structures of a few carbonyl complexes with two or more metal atoms. Such complexes fall into the category of polynuclear metal carbonyls. Here I have shown decacarbonyl dimanganese 0. Decacarbonyl dimanganese 0 is made up of two square pyramidal manganese CO5 units, and these units are joined together by manganese-manganese bond. As there are two manganese atoms present in the complex, this is a polynuclear metal carbonyl. A similar metal carbonyl complex is octacarbonyl dicobalt 0. Here, the metal cobalt is bridged by two carbonyl groups. Now, we will see the nature of bonding in metal carbonyls. In metal carbonyls, a metal carbon sigma bond is formed by the donation of lone pair of electrons on the carbonyl carbon into a vacant orbital of the metal. Also, a metal carbon pi bond is formed by the donation of a pair of electrons from a filled d orbital of metal into vacant antibonding pi star orbital of carbon monoxide. This metal to ligand bonding creates a synergic effect and strengthens the bond between carbon monoxide and the metal. Thus, you can say the metal carbonyl bonds possess both sigma and pi character. Now, before winding up the session, I would like to bring your attention to the importance of metal carbonyls. Do you know impure nickel is usually converted to nickel tetracarbonyl and further decomposed to yield pure nickel? Likewise, there are manifold applications of coordination compounds which we will discuss later. Now, let's summarize what we have learned.
Manorama Horizon. Learning made simple.